Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and I am here to welcome you to today's webinar, How to Build a Basic Edge Cloud. We are here today to talk about this topic for a bunch of reasons. Now, I know a bunch of you are interested in this because, well, frankly, we have a lot of people who registered for this, which is awesome. But also, I have been banging on this for a while, and you'd think there would be more information out there on how to actually go through the practical matters of building a simple edge cloud, but there really isn't. So what I did is I said, all right, I'm going to get somebody who knows what they're talking about to come in and do a webinar for us. And so today we have Mark Monnier. Hello, Mark.
Hello, Nick.
Okay, so Mark, tell us what you do that qualifies you to talk about this today.
Well, first of all, thanks a lot for inviting me to do this webinar, Nick. I'm new to Mirantis. I've recently joined from Docker. And at Docker, I was involved in a lot of discussions with customers looking to do edge projects. My role at Docker is a technical strategic alliance director, and I'm bringing that forward now to Mirantis. What that means is I get to work with partners to bring new features to the cloud native development world that specifically deal with challenges at the edge.
All right, awesome. So you've been kind of playing around with this, you know what's involved. So that's great. So that's why you're here today. Next, let's talk about the agenda. The first thing that we're going to do is we're going to kind of give you a level set on, all right, what is this edge thing? Why does it matter? And we're going to do a demo of an actual edge app. So you have something tangible, well, reasonably tangible, to tie all of these concepts to, because at least in my experience, it's been this nebulous thing that everybody's talking about and nobody's getting specifics about. So we're going to give you actual specifics. And then we're going to talk about the various challenges in creating actual production edge applications. And then if we have time, we'll talk about sample use cases, and hopefully we'll get some Q&A in there. All right. So, Mark, talk to us about edge and what it is and why it matters and why we care about this.
Sounds good, Nick. Well, first of all, why are we interested in edge here at Mirantis? Well, to be honest, it's because our customers, like you, are asking for the same tools they use today for cloud and data center app management to be extended to support applications residing beyond the data center. What we're seeing out there is a progressive change in how data is consumed and generated. There's a surge of data being created by IoT devices, such as sensors, cameras, and tools that are either sent up for processing or more recently being processed locally with more advanced applications. And I'm sure you've heard this before, but it's worth mentioning. Every company out there is becoming a software company. Now, all of this change is creating a need for applications to reside further away from the data center. This minimizes the burden on the network and increases the robustness of the overall system, not to mention the improvements in latency. Now, to maintain modern development practices and to continue to manage apps from a control plane, we need to ensure that proper layering is in place so we don't lose visibility of these apps out of the edge. We need to maintain accessibility by a central command center to roll out updates and ensure that they're running optimally. Now, let's be clear here. When I say from a central command center, that's not necessarily your headquarter. This could be an edge environment where you're managing your applications a lot closer than from a remote headquarter environment. So all of this said, the function that is accomplished by apps and feedback loops from a data perspective should be minimized to reduce latency, to increase reliability, and to optimize the traffic on the networks. In other words, the factory with its gateway or server and all of its peripherals must be able to continue functioning even if the link to the regional cloud is not accessible. Now, one can extend this further, right, Nick? We can extend this further to have updates gated closer to the end nodes and to be ready to deploy without the need for a link to the central control.
Okay.
Yeah.
Okay. So that gets us back to a little bit more of what we had been talking about early in the cloud days, a little bit more decentralized. So now I have an edge application in mind. And if I were to kind of translate that to this diagram, this is, and those of you who read the Mirantis blog, you've probably seen this app already because we started talking about it. But it's an app where we have security cameras that that are, you know, taking in whatever area they're taking in. And the first step close to the camera or even on the camera would be to detect whether there are any faces. And if there are any faces, they could go to this kind of regional edge cloud to determine who that is. Is that somebody who's supposed to be there? You know, basically compare it to a list of known faces. And if it's not, then it's a stranger, and let maybe the central cloud know, and then the central cloud can maybe log, hey, there's been a stranger here, and send you an alert. Does that sound like a correct mapping?
Absolutely. I think this maps quite clearly, Nick. Have you considered putting all this in containers?
As a matter of fact, since we are now doing so much Kubernetes, that was my next step. So let's talk about why we'd want to do that, and then we can talk about how I would do that.
Okay. Yeah, so I think there's some clear advantages of using containers or that construct to build your applications and deploy them. For one, it lends itself very nicely to scaling an edge deployment, especially for lifecycle management of the apps. You know, in that same line of thinking, you can develop applications in containers and then stage your rollout. What I mean by that is you can take your application, run it on a server initially, have your end device push the data to that server, get that up and running, and then once you're ready, you feel comfortable moving that application into the device itself, you can do that. And if your application is completely contained, you'll be able to make that migration a lot quicker.
Okay, so that would be like me developing on my laptop, and then when I'm ready, just pushing it to the actual camera device.
Well, it's actually more than that, because you can develop it on your laptop. Yes, you can debug it in the cloud. You can then run it in your live environment on the server prior to migrating it into the camera. Yeah.
Ah, okay. All right. So if we were to translate that to this demo app, here's what I've got. Okay, so we've got the camera, which does the actual. So we've got the camera that streams to a container that does the face detection, and if it finds any faces, it sends them to a Kubernetes cluster that I've got running in this case, Google Cloud, and it does the identification. And if it finds any strangers, it sends them to another Kubernetes cluster running in this case, Docker Enterprise that I think it's running on AWS. Right? Does that sound correct architecturally?
Yeah, that's exactly it. So you're breaking apart your application into microservices, and you've got various elements running in each one of these environments. And as you can see from the arrow and the nice text there in light blue, as we go up the chain, you're lowering your resiliency. So you got to worry about, potential breaks in your network. Your cost of data increases. So you're doing the right thing here by minimizing how much information you're sending up. And of course, latency. So if you need to react quickly, you want to do that in that bottom right box.
Gotcha. Okay. All right. So let's see how this actually works. Okay. So I've got, let's see how if the demo gods will smile upon us. So we have three regions here. We've got the camera, we've got the regional cloud that does the identification, and we've got the central cloud. So if we start with the camera, I've got a Python script here that's going to just, these are very, very simple scripts, by the way. All we're doing in this case is taking my video camera and then dropping an image into a directory called to be searched. That's it. That's all this is doing. So we can run that. So if I did Python 3 camera.py, okay, so that's going to come up, and this is what's being seen by the camera. Hello, everybody. And you can see here that it's dropping once a second. So every 25 frames, it's dropping it into this to be searched directory. And you can see that they're disappearing as well. And the reason that they're disappearing, and we'll go ahead and just kind of stop that one because we don't need to keep sending it. But you can see here, and what's going on is I have a container that is running in, let's make sure I only have the one container. Yes, I do. So I have a container that's running in Docker desktop, and you can see here, so it's, next one is going to go 225, 225, there you go. And what it's doing is, if we look at Frame Analyzer, which is the script that it's doing this with, it's just looking at these images, looking for faces, and if it finds any faces, it is sending them via HTTP to the second container, which is running on Google. So let's go ahead and drop over to Google. Gotta drop out of presentation mode to do that. So here we are in Google. Here we are in Google Kubernetes engine. We look at the workloads. This is the only workload we have, and we can see that if we grab the container logs, we can see it's that check image script that we were talking about. So let's see what that is. So that check image script, coming back to the Finder. So we're going to pop over to our regional cloud, and that script is just this receive frame. And what this is doing, all this is doing is, so check image. This is just a Flask script for those of you who are interested in HTTP. So this script, all this is doing is it's taking the file and it's running it against these scripts that are in this known, these images in the known users directory. And the known users directory is just a bunch of files that are pictures of, in this case, Star Wars characters, because, well, you know, Star Wars. So now, if it finds anybody that is not recognized, then we're doing the same thing. We're using HTTP. In this case, we're sending it to a script that is running on Amazon in Docker Enterprise. Let's go back and look at that. So we come back to Docker Enterprise. We look at our Kubernetes resources. We're in our Edge demo namespace. You are seeing all of this, I hope. Yes, you are. Okay.
Absolutely.
Pods. Okay. I was like, I hope they're seeing all this. So if we look at the pods that are running, This is our one pod. And if we look at the logs, here's our send mail. Okay, so now we come back and let's see what that is. We come back to our central stuff. In this case, it's just a Python script called report stranger. And as you can see here, the send mail URL is just a script that goes ahead and sends an email that includes the image. So if I were then to pull up my actual email, there we go, stranger alert. So there you can see these are the images of that we had seen in the camera. Now, obviously there are tweaks that we would do to this, like you wouldn't want the same image, the same person over and over again, but this is just a simple demo. You see, there was no rocket science involved in this. This was a very simple, very straightforward process to build what is, by your definition, an edge application, correct?
Absolutely. You've taken
Mark?
your application and you've expanded it across multiple regions. And obviously some of those images are running outside of the data center in end devices.
Right.
This is
right.
a very good example of a simple edge deployment.
Excellent. Okay, so we have succeeded in doing a basic edge cloud. But I have a feeling you're going to tell me there's more to it than that.
Well, there's definitely different paths we can look at now. And this is definitely one that is interesting to me.
Okay.
All right, so Nick, you presented the simple example of an edge environment. You're running application down to your device. Now, what would be interesting, what we'd like to jump into is looking at how one would scale such a deployment. And the example here would be, what happens if you have 1,000 cameras in 100 different sites and you want to manage these devices and these applications? And again, you want to leverage these modern tools. So what's available to help us with these scale outs?
Okay. So you tell me.
Well, you might be familiar with application registries from working with containers in cloud and data center.
So now, the registry is where the image of the application sits, and we can do a Docker pull, or that's where Kubernetes gets the image from when it's instantiating a pod.
Yep, it's a store of, I will say, applications, because it's more than just images nowadays. A lot of these registries can hold a lot of the artifacts around your actual image. But the idea here is that you have a repository of images. And in this repository, in your primary location, maybe at your headquarters, now there are other registry features such as mirroring and caching that can help with moving your applications automatically through policies, for example, across your different regions. So these repositories include these policy-based promotions to help automate the distribution of images across the globe, but more importantly, across various networks. So from your central cloud down to your regional cloud. And these can be used at the edge to receive images when the network is available. So maybe you predefine at which point images get pushed from a primary registry to a mirror registry. And they can help with dealing with intermittent networks. And of course, when you're thinking about these registries, especially when you're scaling out, you really need to consider how it's going to reduce the amount of traffic on your networks. Image repositories are robust, they're secure, they support policies for automatic transfers, they support RBAC. So it's a foundational tool for cloud native development. Okay, and we'll explore this a
Okay.
little bit more, in throughout this presentation.
Aha. Okay. All right. Sounds reasonable.
Okay.
All right. So let's talk about this from a practical standpoint.
Yeah, exactly. So here's a picture of what the flow of applications would look like. So this is the simple high-level image. On the far left here, you've got a number of ISVs creating images. So this is interesting now. We're showing that applications can come from third parties, from internal employees. They initially get put through a registry like this one, where you stage your applications, and then once they're ready, they get promoted and sent across to a mirror registry. And of course, this can all be done through policy. You're not standing there and pushing with a button these applications across. You set up your policy,
Right.
and then you automatically push images or pull images back and forth. And then once it's in your local environment or a little closer to your end devices, it matters less what happens outside of this followed site. At that point, you can manage the applications and the last mile of transport to the end devices locally.
Gotcha. Okay. So if we were to translate this over to the demo app, basically the end devices would be the cameras and maybe the regional clouds as well. So any updates that, me as a vendor do, I could then automatically push to my cameras, to my customers.
Yeah, yeah, exactly. So as you scale it out, right, you would have this mirrored registry at each one of your customer sites, if that makes sense, or at a local, more regional cloud environment where you can, from that location, fire off these updates really quickly.
Gotcha. Okay, that makes sense. All right. So, okay, so then so from a real world sense, it's more than just that.
Well, yeah, exactly. And then comes a question, how do you secure all of this? What are the tools available to help you manage security from end to end? So at high level, what we're looking at here is an extension of the chain of trust that starts from the developer and goes all the way to the end device. This is
Okay.
one example, right, of how this can be accomplished with cloud native development tools. So let's walk through each one of these points and describe, what this does. So again, far left, your images are received. They could be signed by the originator, and ideally they're built from known sources. They are then received, their ingress into the repository, where they go through various stages before they're in a position to be shared out to another repository. Those steps include scanning the incoming images, signing them, telling the Edge gateway or the Edge repository these are secure, and then promoting them. So then these images go through this transport where, of course, all communication between repositories is protected by TLS communication standards. And then they're received at the Edge gateway and they're validated. So we know that images that are received here are coming from a known source.
Gotcha.
Once they're here, they then get passed on to end devices. And of course, in the end device, there's a possibility or an option to verify signatures. So you can validate that the applications have gone through the right steps and are received and are checked for any compromised images. So you're really validating again right at the last endpoint.
Huh. Now, is this all we have to worry about when it comes to security?
In a nutshell, yes, but there's a lot of details.
Okay.
So let's jump in. What we'll do is we'll concentrate on this area here, the last mile of security, because that's where I think things extend from what we're already used to in a cloud environment.
Okay.
So the first thing we need to do is identify the end device. We need to know who we're talking to when we're sending an application out to a device. So if a device is being installed out in the field, we'll want to whitelist the device before letting it connect with the control plane. So this can be done in many different ways. It needs to be appropriately handled given your environment. So, you know, if you're in a factory and you're receiving your hardware and you want to connect it to your repository, which is also local, you can simply walk over and, you know, pass over the keys. If it's more remote, there might need a call home procedure. Again, there's many ways to do that, but definitely you need to establish first that you can identify the device.
And when it comes to hardware and trust and all that, this sounds like we could probably do a whole webinar on that if we wanted to.
Yes, we definitely can. And you know what? I do need to watch for time because this could take. I can take up the time.
Exactly. Yeah. And if you're listening to this and you would be interested in a whole webinar on this, definitely let us know in the comments, because you know we're always looking for that kind of feedback. But go ahead.
Yeah, and you're bringing up a good point. It's really important to consider how you protect keys and end devices. This is where things like TPM come in, Trusted Platform Module, and they should be leveraged to store credentials securely on the end devices. And that's because these end devices are out in the open. They're not just sitting behind glass doors in a data center.
Right.
So identifying the end device is step one. You also need to ensure the integrity of that device. You need to make sure it hasn't been compromised.
Because this is something that anybody can, you know, have sitting on their workbench and they can mess with it.
That's right. So you can identify that, you know, camera A is out there, but if you don't know that it's in a good state, there's a big risk. So there are tools available that you can leverage to, you know, ensure that the state of the device is in the right order. One tool that can be leveraged is IMA, Integrity Measurement Architecture. And basically what it does is extend the root of trust to include the secure boot flow and key elements of the container runtime, basically things that are static. It takes a measurement and then puts that into the TPM and makes it available to your control plane should it need to validate the end device. So what's happening there is your control environment, your central control environment can verify that the end device is who it says it is based on a key, and then also check that it's in the right state based on a measurement.
Got it.
That's how you would ensure that your device is both who it is, who you think it is, and that it's in a proper state.
Okay, and so how do we combine this with the proper image then? So we know the device is okay. How do we know that it's running the right image?
Right, so the next step. Well, there's actually a couple other things we could bring up quickly before we jump there. One is if you needed to do more of a lockdown on the device, you can use Cell Linux to control which resources applications have access to. So there's some additional available tools. And then you can protect images at rest that sit in the device by encrypting your volumes. And again, you know, you place the keys in your TPM in that case.
Gotcha.
Now, what you were asking about, so how do we now ensure that the applications that are being sent to the end nodes are valid? And for this, we'll go through an example with Docker Content Trust, which is a tool that I'm familiar with, that we use, where images which are signed in the registry can then be validated in the end device. Okay. And here, what's been done recently with this environment is basically leveraging the TPM to create keys and sign certificates So you're taking advantage of your hardware-backed security in order to, verify these images.
Okay.
Yeah.
All right. So that sounds good. So, all right.
That
So
covers
then,
really the last mile, right? From the registry down to the end device. You can identify your device, you can check that it's in the proper state, and any images that are sent to it can be validated before they are run.
okay. Now, but as a developer, I don't necessarily have access to like TPM and all that. So how can I code and make sure that I'm taking advantage of all the proper security things without having to deal with that?
Right, and that's a very valid point. Cloud native development ideally doesn't need to worry. The developers don't need to worry where the applications are running. This is something
Because I
where
hate hardware.
you hate hardware. So it's a problem.
Sorry, go ahead.
Nick, it's a problem, right? It's definitely something that needs to be addressed. And we've taken steps towards making security more agnostic. In October of 2019, so about 6 months ago, we launched a project together with a partner called ARM Semiconductor, to create this abstraction layer that basically abstracts all the various security enclaves in both hardware and in the cloud so that applications can be developed, still leverage these primitives, but in a common way so that the commands that they would use are all the same regardless of where the application is deployed. Now, this project is an open source. It's an initiative that we've kicked off with ARM. It's not tied to anything specific to ARM. It supports both, x86 security hooks. It supports PSA Trust Zone from ARM. It supports, the idea of cloud security environments such as HSMs. Yeah.
Okay. All right.
Okay, so this is where, Nick, you can develop your applications, not need to worry about what it's going to run on, the specifics of the hardware. You simply call out signing of images, validation of keys, and be assured that it's leveraging the most secure mechanisms available for the deployment environment.
Good, because that, like I said, I'm a software engineer. I don't want to think about hardware. But since you've brought it up, ARM. Now, there's what is the deal when you have like multiple architectures?
Yeah, and it's something that comes up on the edge in edge discussions all the time, right? So edge devices often come from hardware manufacturers who pick the most efficient chips for the task. It's not up to the developer to pick that architecture. Often it's a third party who's developing their product, and you don't have a choice on the architecture. That can cause some problems. Last year, Docker and ARM worked together to create an environment where applications can be developed for both ARM and x86 in the same build cycle. You're essentially writing your application once, and when you call out a command called buildx in Docker development environment, Docker desktop, it creates an image for x86, for ARM32, for ARM64, and can push that up to your repository.
Okay.
So that's
right. So again, I don't have to think about it.
Exactly. You don't need to worry about where it's being deployed. So it really adds that separation, allows the app developer to concentrate on the nuances of building the app, do what they're best at, and then let the operator decide where the application gets deployed. So if we look at your example here with the camera, right? Imagine that you have two cameras, one from ARM, one with x86 CPUs. The ability to push your applications to either environment is pretty powerful.
Right. Especially, Edge is a case where there's a lot of these different chips running around, because they all have, like you say, they all have uh, different advantages. Some are low power and some are high performance, and et cetera, et cetera, et cetera. So that's good.
Yep.
Okay. So what other hardware related things do we need to think about?
Well, since I know how much you love hardware, thought I'd bring out another another topic.
GPUs though, but this is GPUs, and I'm happy with GPUs because machine learning is my jam.
That's
So
right.
there
You
you
need
go.
GPUs and TPUs and all the rest. So these are viewed as hardware accelerators in the application development world. The reason they're seen as accelerators and not, another architecture for, multi-arc builds is because they're treated more like peripherals from a application perspective. You create your applications, you deploy them on CPUs, and then you have these hardware specialists that are designed to perform specific functions more efficiently than what you would do in a general purpose CPU. Now, I bring this up because it's important to understand how these are handled in a container runtime environment and how they are made visible from an orchestrator perspective. So if you take, for example, GPUs, and if your camera had a GPU in it and you wanted to take advantage of it, first you would need a driver that makes that GPU accessible from the runtime environment. And then you need a plugin. So together with the driver and the plugin, you now can access and run your application or part of your application on the GPU. And then integrating that into the control plane is key. So when you're deploying your applications, you want to know, does this node have a GPU attached to it? How many GPU nodes are there? And then you deploy your applications on the right nodes that can support that application, or consider that your application will run a lot slower if that hardware accelerator is not available.
Right. Gotcha. Okay. All right. So are we covered now on the hardware? Can I
I
breathe
think
a little
so.
bit?
I think so.
Okay.
It's funny because Edge, right? It always brings up these nuances of hardware because it's part of this new challenge with Edge. You're dealing with a lot more variability out there, and we're seeing that. We're seeing that on all fronts. But this is it.
Exactly.
I am done now with hardware.
Okay. All right. Good. So talk about a sample. We have a sample case study here. So give us like a 2-minute description here, and
Okay.
then we'll get into questions.
I'll make this. I'll go through this quickly. So in this case study, imagine that these sites are managed by a central manager sitting up here in the cloud, or a system integrator. Because now what's happening at the edge is there's a lot more actors involved. There's a hardware manufacturer who's providing these devices. There's often a system integrator who manages the site for the customer. There's ISVs providing software images that do special functions and that need to be then brought down to these devices. So here's the picture here of a cloud environment together with customer sites that are not necessarily always connected to the cloud. In fact, this one here is air-gapped, 100%.
Okay.
Now, the beauty of these tools in a cloud native development world is what you run and use in the cloud environment should look the same as what you use and run in your site, on your site. So if you replicate what you have up in the cloud onto the site, this is what it would look like. You would end up with a registry that is either a mirror image of what's in the cloud, receiving specific applications that are applicable to this environment, or they could be cached, but more cases than not, they're a mirror image. In the case where you're air gap, you simply carry those images, by hand with a mobile device or a USB stick or something like that, and you drop them into your local registry. At that point, you're now autonomous from the cloud in a sense, right? If the cloud is there and a control plane says, hey, push this application all the way down to the end node, no problem. It'll type it down. The control plane here will have, policies set up, and the application will run on the end device. Now, if this connection is not there, or if it's expected to be intermittent, this control plane can manage everything in this environment, including bringing up new devices from scratch. So if one of these nodes dies and you want to bring one up, where are you going to get your latest application? Well, you don't want to rely on the cloud. Like, this site could be a ship out in the ocean, could be, a factory that's running, in I don't know, somewhere really far from the network. In this case, you want to be
could be a turbine in the middle of the desert.
Could be a turbine, could be an oil rig. There's a lot of use cases where, these environments exist.
Okay.
And that's really it in a nutshell. So what you have here then is you're going to worry about your last mile of security in this environment, right? So everything we talked about security kind of resides from this local environment down to the end devices. You're really worried about just making sure your images are sound when they're received here, that they come from the proper cloud, but then, everything else is managed locally.
Okay. All right. So we're going to go to Q&A. But I just wanted to let you know that we do have this white paper that you can download. I know a lot of you were expressing interest in security, so you can go ahead and grab this white paper. That will also give you a lot of information. And if you have questions, please go ahead and drop them into the questions pane right now, and we will start to look at these questions that you have going on here now. So wow, a lot of questions, and that is awesome. So let's see what we got here. Does Docker platform support GPUs? Mark.
Yes, it does. As of Docker 1903, I think that's been added. I think it was 1903 where we added GPU support. And there's obviously more work happening to, add functionality from an orchestration perspective. But in a nutshell, you can use GPUs and up and running. Yeah.
Okay. So, all right. Is it passing? I'm assuming we're talking about the demo here. Is it passing the video data to the Google container, or is it passing a container to the Google platform? So in the case of this demo, what we are actually doing, and I'm just going to go back to this. In the case of this demo, this container is just passing a frame of video to another container that happens to be running on Google. Go back to list of questions. Okay, so Mark.
Yep.
Somebody is asking if you can explain again about the mirror registry and the cache. So let me pull that slide up while you do that.
Yeah, and I see another question here about Docker EE versus Docker CE and DTR. So I'll try to answer both because I think it applies. Okay, so mirror registry versus primary register. So what this could be used for, let's explain what this would be used for in a practical sense. If you are developing applications, and again, this is specifically for an edge use case. There's obviously value in mirrored registries from a global development perspective, and also just having your repositories around the world. There's policies and rules around, some applications need to be kept in certain geographical locations. But focusing on Edge here, the idea here is to have a copy, and it could be a smaller copy of your registry that's more local to your environment. So it's the concept of having a registry that copies certain images from your primary registry that have been promoted and are ready to be shipped out onto a local registry that can then leverage these applications for updating the local environment. If that makes any sense.
Okay. All right. We have a question to access. Well, you know what? Let me do this one first, because this one is related to that question. So video data isn't passed to the central Google location. It is the central location that pushes the approved images to the Edge, and the Edge does all the facial comparison. So let me go back here, because I think we're getting a little bit confused between unfortunately the word image is somewhat overloaded. So in this case, how I would do this is Docker Enterprise running Docker Trusted Registry. Okay, and so my camera would pull the trusted signed container image that is the template for the application from Docker Trusted Registry. It is then pushing video images up in this direction. So I hope that makes that more clear. Okay. Let's see. Where are we here? Mark. No, I answered that one already. Okay. Here we go. My question is around multi-tenancy. How can multiple enterprises push configurations to the end CPE or camera devices with a multi-tenant central controller hosted in the cloud? How can we build a hierarchy to address latency aspects?
Oh, I like that question. That's a good one.
I thought you liked.
Good choice. All right. How do you deal with multi-tenancy in Edge deployments? And you know what? We've danced around that topic quite a bit with customers and partners. So what we came up with that I think makes the most sense is you deal with multi-tenancy from an image perspective, from a repository perspective. You really need one owner for that CPE box. And just to clarify, CPE is like something that sits at the premises, right? It's your gateway, or in this case, you're saying also the camera. So you need one entity that manages that device. In our environment here, we're saying the control plane that's local or in the cloud has a direct pipe to that device, and it aggregates all the applications, configurations from various sources and makes that available to the device. And the reason it's clear to have that one path, what we've seen is if the device has issues in the field and you need to try to figure out what's happening, somebody needs to be in a position to say, this is the configuration, these are all the applications that are running, they've been tested independently, obviously they've been developed by third parties or internally, and they've been tested together in that environment. In some cases, the applications talk to each other and there's APIs, you want to make sure they're sound. But that's the point here, is that you need to have one person in charge that you can go to and say, what's happening to my end device? And we really control the multi-tenancy at the repository level. Does that make sense? I hope that makes sense.
Yeah, yeah, I think so.
Like in the case where there's multiple repositories, you can say, we're going to gate all the applications at the headquarters. Maybe it's a system integrator says, we're going to validate all these different configurations and applications there and mirror that down to the local repository. That would mean then that the local repository, the local environment, does not have access to independent software from various sources. You would gate that at your central location. Yeah.
Gotcha. Okay, that makes sense. The last thing you want is your edge devices running like a botnet. That would be bad.
Well, you know, Nick, it's not
Okay.
even that. It's if there's just a configuration issue, who do you call? And that's the question that comes up
Yeah,
all the time.
that's
Who
true.
do I call when something goes wrong? You want to establish that, you want to
Yeah,
keep that in mind when you deploy this out at scale.
that is true. Okay, so let's see. To access an application that is present on an edge cloud, for example, through a mobile network, a gateway such as PGW or UPF is required. The question is, are these network functions ready to run in containers? Do containers offer the necessary security for such network functions? Okay, I can actually answer this one. So what we're talking about here is the transition from virtual network functions or VNFs to containerized network functions or CNFs. And the answer is some of them are and some of them are not. This is a process that is ongoing. And it really is going to depend on the vendor, but ultimately a lot of them will go in that direction. But if they are not containerized, you do have the option to run them as virtual machines. So for example, there's a project called Vertlet. We've got information on Vertlet on the blog. You can grab that, or you can email me at mchase@mirantis.com, and I will send you the information. But Vertlet allows you to run virtual machines as first-class citizens within a Kubernetes environment. So you have that option. Okay, we're almost out of time. I'm gonna take one or two more here. Let me see. Okay, Mark, give us 30 seconds on, can you compare running Docker and container on the edge device versus an application written in a microcontroller language with the same functionality as the app running in the Docker container alternative?
Absolutely. If you're developing one device and you're pushing it out, you don't need to do updates, you don't need to manage, then you can probably do it more efficiently running microcontroller directly, microcontroller software. The challenge though is when you try to scale and you try to manage and you try to create this from a cloud native perspective, which gives you all these tools to accelerate your development, that's where the transition comes in. That's where it breaks, and that's where you really need to consider tools to run those applications like containers. Now, running an application in a container itself doesn't add latency. It's transparent. It does, though, add a burden from a processing perspective a little bit. You need some more like RAM and you need some more flash in order to, hold the environment. But the advantages of that you're getting with containers are what's driving this transition, this change to more cloud native development environment, even for IoT devices that are limited in hardware.
All right. So I'm going to stop you there because we are at the top of the hour. This has been a blast. I've really enjoyed it. And I want to thank everyone who has stayed with us because this has been great. We have a lot of questions that we did not get to. We are going to do a blog that answers them. And also, if for those of you who are asking about the code for the demo, you will see that on the blog in a series that has already started. If you want to be notified when those episodes come out, email me at nchase@mirantis.com. Also, I'm sure you'll be getting an email after this webinar. And I want to thank all of you for coming out. I want to thank our guest today, Mark Mounier, and as always, our super producer, Michelle Yakura, without whom none of this would be possible. And I want to thank all of you, and I hope you have a wonderful day, and we'll see you next time. Thanks.
Thanks, everyone.